Welcome, math nerds, to my channel which focuses on IB math at standard level and higher level. It may also be helpful for others not taking IB math, but the videos are specifically made for the IB program. In this video, we will cover a high-level overview of parabolas, and later videos will delve into this in more detail. So, what are parabolas anyways? There are many equivalent ways of defining a parabola. For example, if we were to draw a horizontal line and then choose a point above that line, the line here gets a fancy name, directrix, and we call the point a focus. Then the set of all points which are the same distance away from the line and the focus would trace out a parabola. Although this is a cool geometric interpretation of the parabola, parabolas in IB math are typically defined geometrically with graphs, or algebraically with equations. Let's look at the first way of defining parabolas, graphically. Parabolas are U-shaped curves that can open in any direction, up, down, or in some other arbitrary direction. In IB math, typically the parabola will be a curve facing upward or downward with a line of symmetry that divides the parabola into two symmetrical halves. This line is called the axis of symmetry. The portion of the parabola to the left of the axis of symmetry can be reflected to create the portion of the parabola to the right of the axis of symmetry. Suppose we take a downward-facing parabola and travel along the parabola's path from left to right. If we were to measure out the height above the x-axis, it would be increasing and then decreasing. The point where we go from increasing to decreasing is a turning point called the vertex of the parabola. This comes from the Latin word vertere, meaning to turn. If parabolas open up, the y-coordinate of the parabola will be a minimum. Conversely, if the parabola opens down, the y-coordinate of the parabola will be a minimum. We may also define parabolas algebraically. For example, all points that satisfy the equation y equals ax squared plus bx plus c would trace out a parabola, and the equation would be called a quadratic equation. Here, a, b, and c are just numbers, constants, and a has to be a non-zero constant. The word quadratic comes from the Latin word quadratus, meaning square. If we ignore the last two terms and let a hold the value of 1, then the equation becomes y equals x squared. Taking a geometric approach, let's consider a square with length x. If the input is some length x, then the output x squared represents the area of this square. The defining feature of a quadratic equation is that it will always have a squaring term, a term that takes an input and performs the operation of squaring. Parabolas also have many features. For example, the axis of symmetry and the vertex, which we've met before, as well as intercepts, which we'll explore now. The y-intercept is the point where the parabola intersects or meets the y-axis. Since the x-coordinate of the y-axis is always 0, we can use the equation x equals 0 to represent the y-axis. Therefore, if the y-intercept lies on the y-axis and the parabola, we can set x equals 0 in our parabola to find the y-intercept. The x-intercepts are the points where the parabola meets the x-axis. The x-axis can be represented with the equation y equals 0, and therefore the solutions to ax squared plus bx plus c equals 0 gives us the x-intercepts to our parabola. What's interesting about the parabola is that the x-intercepts don't always have to exist. However, a y-intercept will always exist. That's it. Thanks for watching. If you enjoyed this video and found it helpful, please like the video and subscribe for more IB-related math videos.